Okay, so honestly, today we just add some other kinds of factoring, right, to what we already know. So in the last class, we learned how to factor something which I call a simple quadratic trinomial. And it was simple because that coefficient right there is a 1. Okay, and if it was, then all we had to do is think of two numbers, right? And it was a one-step process. Done, right? If that first coefficient, the leading coefficient, is not 1, then it's not as easy as just thinking of two numbers, and in one step you're done. So this is actually the more general form of a quadratic trinomial. Ax squared plus bx plus c. So again, this is the one that I would call simple. And this is the one that I would call not simple. And that's just me. That's not, the book won't call it like that. So like I said, this is the standard form of a quadratic trinomial. Meaning it has a, b, and c. When we did the simple, we didn't have the a there. The a was there. It was 1, right? But more generally, it's ax squared plus bx plus c. And we'll use those letters. When we get into solving equations with quadratic formula, then you use a, b, and c is how you solve it. Okay, so let's see. So factor. So I'm going to show you two different ways to do this. Okay, honestly, this is the kind of factoring that confuses us a lot, not just in Algebra 1, even in Algebra 2, even in pre-calculus. You know, they're still making mistakes with this. But the way the book teaches it at the beginning is actually an option that I don't usually talk about much, which works sometimes fairly easily, like here, and then sometimes not quite so easily. But it's essentially just guess and check, right? Just guess and check. If we know we're going to factor it into two factors, and we know that the first term is going to be 2x squared, then it means that in one of these it's going to be 2x, and in the other is x. Because are there any other factors of 2 except for 1 and 2? No, that's it. I mean, it's got to be 1 and 2. We know that the last factor, the last term there is 3. Well, how are you going to get a 3 by multiplying these two factors together? It must be that the second numbers in parentheses are either 1 times 3 or negative 1 times negative 3. That's the only way you would get a positive 3. Okay. Now, the only question is, should this be, oh, sorry, shouldn't do that yet. Edit, undo. Edit, undo. Do you think it'll be positive 1 times positive 3 or negative 1 times negative 3? Given that this number is a negative, right? Since this is negative, then probably the factors that we would be looking for are, the factors of 3 are negative 1 times negative 3. So the only question is, should I put negative 1 in the first set of parentheses or negative 3? Right? Which one of these is it? Is it minus 1 minus 3, or is it 2x minus 3 times 2x, or sorry, times x minus 1? So, well, it will matter, right? But when I multiply to get the first term, 2x times x, I get 2x squared, and both of these. And then when I multiply to get the last term, negative 1 times negative 3, I get 3. I got to check that the middle term is correct. Which one of these do I end up getting the right middle term? Okay, well, let's multiply, right? Let's FOIL. Let's just FOIL it, right? 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 1 times x, negative x. And then the positive plus 3. Right? This one would have been 2x squared minus 2x minus 3x plus 3. So which one of those does the middle term add up to negative 7x? Yeah, this is the one that it works. So, I mean, because the 2 is a prime number, it only has 2 factors, 1 and 2, and the 3 is a prime number, right? 2 factors, 1 and 3. There's actually not much to guess and check, right? There's a little bit of playing with the sign, but for the most part, these, you could have checked 2 things and found the right answer without going through a long process, which I will teach you in a second. Okay, so like on this one, again, we're still in the same kind of position that the first number is a prime number. It's only got 2 factors, so we know what will be the leading terms in parentheses here. 3n has to be in one of them, and n has to be in the other. Okay, this is a prime number, right? Negative 5. That's either going to be a plus 5 times negative 1 or a minus 5 times positive 1. And then we'll have to see like which parentheses do they go in. So at this point it's going to be a little bit of guessing and checking, What should the next one be? Again, there could be 4 different solutions here. Right, all of them are going to start with 3n, n, 3n, n, 3n, n. That's a bad n. Okay, now what we don't know is, should this be plus 1 times negative 5, right? Or should it be negative 5 times plus 1? Or should it be minus 1 times positive 5? Or should it be positive 5 times negative 1? It's got to be one of those. We know we got the first term and the last term right. We just don't know which one of those will give us the right middle term. Can you see it? If in terms of FOIL, you really only need to do the O and the I. Which one of those, if you do the outer terms and the inner terms, they add up to 14n. Let's see, this first one, if you do the outer terms, you're going to get negative 15n plus 1n. Okay, that's negative 14n. That's not right. If I do the second one, I'm going to get 3n minus 5n. That's negative 2n. That doesn't work. How about 3n times 5? That's 15n minus 1n. There you go. There's your 14n, right? This is the one right here. So, I mean, I would call this method guess and check, right? Just guess and check. The checking is check to see which one of those gives you the right middle term. So try this one. See if you could come up with the right factors. Again, the first term is, the coefficient is 2. It's only got two factors. It's going to be 1h times 2h. You know that. You just got to figure out where do the factors of negative 7 go. So again, what are the factors of negative 7?
1 and 7.
It could either be 1 times negative 7 or negative 1 times positive 7. Right? It had to be one of the two. Then you had to check like which one of them is it going to be, and where do they go? Which one goes with the 2h, which one goes with the h. And everybody got this that I saw. 2h minus 1, h plus 7. Right? I mean, when you're thinking, you see a positive 13H, you got to be thinking like, okay, well, that's probably 2 times positive 7, right? I mean, that's what I would think first thing. So it's a little bit of a guess and check. I think the next one, try this one. What's different about this one than the one we did before?
It's not negative.
Well, not just that. Is 4 a prime number? No, you can have a little bit more to check, right? Because the 3 will be easy, right? You know that 3 could only be 3 times 1, so we could say that's 3t times t, right? But the last number, 4, could actually be 1 times 4. It could be 2 times 2. I guess it could be negative 1 times negative 4, or negative 2 times negative 2. But what do you think it would be? Since this middle term is positive, it should be positive. We're dealing with positive numbers here. Okay. So try to guess which numbers are going to go after the 3t and after the t, so that when you factor it, you get the right middle term, 8t. Well, so I mean, really, there's only 3 possibilities you have to check, right? You could check the 1 and the 4. You know, it could have been a 1, it could have been a 4. You could check 3t plus 4 times t plus 1. And then the last, it would be the same, right? It's 2 times 2. So let's try them all and see which one gives us a middle term of 8t, right? 3t times 4 is 12t, plus 1t is 13t. That doesn't work. 3t times 1 is 3t, plus 4 times t is 7t. That doesn't work. 3t times, sorry, that was a 2. 3t times 2 is 6t, plus 2 times t is 8t. There you go. So it must have been this one right here. 3t plus 2, t plus 2. So essentially, you're foiling. I mean, you guess and you foil. Did I get the right thing? No. Try it again, until you find the combination that works. Okay. Try this one. Let's say on this one, look, since you got the 4 is the first term, everyone we've done so far, we've really kind of we had the first term set before we started. Might be easier on this one to start like this. 5 could only have factors of 1 times 5 or negative 1 times negative 5, right? So which one do you think it's going to be if the middle term is negative? It's definitely going to be that they're both negative. So if you start with this, minus 1, minus 5, and then try to figure out what goes in the first position, because you're going to have to try again. 4's got more than just 2 factors. Right? Which are going to be the 2 leading terms of those binomials so that you produce a negative 9s? Again, there was 3 possibilities here, right? If I started with a minus 1, minus 5, then here's the 3 possibilities. It could have been 2s and 2s, right? That would have given me a 4s squared. It could have been 4s times 1s, or it could have been 1s times 4s. Right? Those are the only 3 guesses that you had to check, right? And which one of them added up the middle term to give you negative 9s? This one, right? S times negative 5 is negative 5s. Negative 1 times 4s is minus 4s. Add them up, you get negative 9s. So this is the right factoring of it. right? The other two, you wouldn't get the right middle term. So all you can really do is just guess using the factors that you know, and then FOIL, at least do the O and the I, see which one gives you the right middle term. Hopefully you set it up for the first and the last term. That was never going to be an issue. It was only going to be a matter of the middle term. Okay, I think my next slide, I'm going to show you, there is a process for this. So there is a way to do this without just guessing, okay? And it works like this. It's similar to what we did for a simple quadratic trinomial, but this time you don't look at just the last number and say, what are the factors of 4 that add up to 8? You say, what are the factors of 3 times 4 that add up to 8? Right? 3 times 4 is 12. Okay. What are the factors of 12 that add up to 8? 6 and 2. Okay. Now, I'm just going to write them down. Could it be -6 and -2?
No.
Why not?
Oh yeah, it could actually.
I mean, it could, but is it for this problem? Because it's a positive 8t, it's got to be positive. Okay, so it's 6 and 2. Okay, these are not, this is not like saying, okay, it's x minus 6 times x minus 2, or x plus 6 times x plus 2. That is not correct, right? With these two numbers, right, that multiply to give us 12 and add to give us 8, we use to split up the middle term. So it looks like this. 3t squared plus 6t plus 2t plus 4. Okay, This got about 5 steps, depending how it works out. 6t plus 2t is 8t, correct? So me rewriting it didn't actually change what we started with. It's still equal to what we started with, but it looks a little bit different. Okay, right? So that was the next step. Next step, group. Put the first 2 terms in parentheses. Right? The plus goes in between the parentheses. Put the last 2 terms in parentheses. Okay, now do greatest common factor factoring on each set of parentheses. Right? What's in common? What's the greatest common factor for 3t squared and 6t? 3t, right? So factor that outside of parentheses. And what's left in parentheses if I factor that from both terms? T plus 2. Okay, how about the second set of parentheses? What's the greatest common factor between 2t and 4? 2. Okay, sets times t plus 2. Okay, if you've done this process right, at this point, what's in parentheses will be the same. It has to be the same, or else there's a mistake. So since we've got 2t plus 2 in both sets of parentheses, we're 1 step away from being done. Right? This is t plus 2 times, look at it like this. I'll use the sound a little bit, but if I take the t plus 2 away from this term, what's left? If I take the t plus 2 away from the first term, what's left? 3t. If I take the t plus 2 away from this term, what's left? 2. So what goes in here is 3t plus 2. 3t plus 2. I mean, it's whatever's in front of the parentheses goes there. So that's a way of factoring without having to just guess and check. Which, if you don't guess right, it could be frustrating. And, I think you kind of expect that you have like a process to go through, not just guessing and checking. It's a strategy. But I would tell you that this kind of factoring, which comes up a lot, as you move on, not probably after the little bit we do here, and then geometry, probably not much in geometry, if at all. But then in Algebra 2 and beyond, it comes up quite a bit. And we make a lot of mistakes with the process. One of the mistakes we make with the process is students will look at the simple quadratic trinomial, the kinds that we did last night, the kinds like, did I already erase it? I think I already erased it. X squared plus 6x plus 8, and think, oh, I'm going to do this same process, this 5-step process, and then get it wrong. Remember, if it's a simple quadratic trinomial, that's a 1-step. Once you got your 2 numbers, you're done. You don't need to go through a bunch of steps to factor something if 1 is the leading coefficient. Let me see if I got another one in here. Okay, now what makes this one just a little bit different?
The first one.
The leading coefficient is negative, right? Now, you could factor this, I could come up with something that looks like, a parentheses, negative 2x, times parentheses, positive 2x. But probably the easiest thing to do is just factor out the negative. First step, just take the negative away, right? If I pull a negative out in front of parentheses, then what does that do to every term inside the parentheses?
It turns it to other sign.
It flips their signs, right? 4x squared minus 12x minus 7. Now we're going to factor what's in parentheses like we already know how to factor, and at the end we'll just have to put a minus in front of it. Okay. But that's not right. I'm going to get rid of these. So I'm going to go through that same process that we did on the last one, okay? So again, the first step is multiply 4 times negative 7. What do you got?
28.
Negative 28, okay? Okay, now we're going to say, what are the factors of negative 28 that add up to negative 12? Well, let's think. 28 could be 1 times 28. It could be 2 times 14. Or it could be 4 times 7. Okay. Now, because they add up to a negative number, we know that the bigger of those two is going to be the negative number. So it's either 1 times negative 28, 2 times negative 14, or 4 times negative 7. So which one of those pairs add up to negative 12?
2 minus 14.
Right there. Okay, so remember, what did we do with those two numbers once we found them?
Make it, I don't know, split up the middle term.
Split up the middle term. Yeah.
Okay, so when you split them up, how do you know which one it was to put in? Do you put the 14 on the left or the right?
It does not matter. So here's her question. I mean, this is important stuff because this kind of problem, exactly this kind of problem, is where we make some mistakes. Okay, so let's say that I go like this, right? She's saying, when I split up that middle term, should I make it look like this? 4x squared plus 2x minus 14x minus 7. That would be one possibility. Or should I make it like this? 4x squared plus minus 14x plus 2x minus 7. I mean, both of them will give you the same answer, and it won't matter. But what's the next step? After we've split up the middle term, what was the next step?
Put 2 terms and we'll put,
Group, right? Group the first 2 terms and group the last 2 terms. Okay. Now, when I do this over here on the one on the right, let me split this up. If I do this on the one on the right, then it's going to look like this: 4x squared minus 14x. Right? The plus goes in between the parentheses, and it's 2x minus 7. If I do it on the one on the left, it's much more complicated. 4x squared plus 2x. Okay, the minus goes in between parentheses, and what's left inside the parentheses? 14x plus 7, right? Because when I put a minus in front of parentheses, it's going to flip the sign of everything inside. So in order that I don't change what I've got to flip the sign. That's because the negative isn't, the subtract is in between the parentheses. You don't have to worry about that if you have, like I did on the second one, where I put the negative term, negative 14x, and then the positive term, right? So, I mean, personally, if I've got a positive and a negative, I always put the negative first so I don't run into problems like that. But if you do it correctly, I mean, either one will give you the right answer. So we're still carrying around this negative. What's the greatest common factor between 4x squared and 2x? Two x, right? They both have an x in them. And what's left in the parentheses if I take away 2x from both of those terms? 2x plus 1. Remember, when you take away a 2x from 2x, it's really 2x divided by 2x, 1. Okay, how about the next set of parentheses? What's the greatest common factor? 7. So factor out a 7. And what's left in the parentheses? 2x plus 1. Remember, it has to be the same expression in parentheses, or else you did something wrong. If you forgot to flip the 7, the negative 7 to a positive 7, at this point you would have had 2x plus 1 in one and 2x minus 1 in the other, and you wouldn't be able to keep going. So if there's something different, it's probably for this reason. So you're pretty sure that the first set of parentheses is right, the second set is wrong. Okay, now we got one more step. Okay. Since they both have a 2x plus 1, that'll go here. And what goes in the other set of parentheses? 2x minus 7. Okay, now if I did it on the right, I have less issues, right, with the flipping and all that. The greatest common factor between 14x squared and negative 14x, or 4x squared and minus 14x, 2x. And what's left in the parentheses? 2x minus 7. Okay, plus. And now, what about the next set of parentheses?
Wait, I'm done with you.
Is there any common factors in the next set of parentheses? No. It's what you would call prime. So you just leave it. Which is good because, 2x minus 7, that's already what we got in the first set of parentheses. Okay, so last step, right? Since there was a 2x minus 7 in both terms, there'll be a 2x minus 7 in the factoring. Okay, what goes in the other set of parentheses? Again, if you think of it, it's like a plus 1 times 2x minus 7. So this is 2x plus 1. And then we had to carry the negative all the way through. So notice the answers are the same. The factors are flipped, but that's okay with multiplication, right? 2 times 3 equals 3 times 2. But otherwise it's the same. So you can split it up. When you take these two numbers, you can put them in either order. I would just recommend do the negative first. And then you won't have any issues. Yeah?
In the beginning, did you have to do like the negative thing? Like take it away?
No.
Okay.
You could have gone, what's negative 4x? Or negative 4 times 7 is negative 28. You would have been doing the same thing. You would have been looking up for the factors that added up to positive 12, which would have made these exactly the opposites, right? So you could do it without factoring out the minus in the end. Okay. So see if you could figure out how to do that one. And you could either guess and check. You could try to follow this process. You can factor out a negative 1 if you want. So here's at least one way of doing it. I said you might have just guessed and checked. There wasn't that much to check, right? Because there was a 3 and a 2. They're both prime numbers. You might have figured it out without having to go through 6 steps or whatever, however many steps. So I'm going to try to do it over here so my voice is carried. So again, I factored out a negative in the first step. So what was left in parentheses, 3x squared plus x minus 2. I multiplied 3 times negative 2 to get negative 6. And I find the factors of negative 6 that add up to positive 1. Right? That would be negative 2 times positive 3. I split up the middle term, negative 2x plus 3x. I group the first two terms and the last two terms. And then I factor each set of parentheses, right? It looks like the first set of parentheses, there's an x in common, so I factored it out. The next set of parentheses was prime. There's nothing to do. So we have a 3x minus 2 in both sets of parentheses, so that makes 3x minus 2 one of our factors, and the other one is x plus 1. And the negative that I factored out at the beginning goes all the way down. Most of you showed me something like this, negative 3x plus 2 times x plus 1. So you took this negative and multiplied, that's fine. It's the same thing. These are the same. Okay. Okay, so now that we have a new way to solve to factor, that means we got a new way we can solve by factoring. Because all the time, the whole goal of this is to solve an equation. We're not factoring just for the sake of factoring. So again, I would have to factor the left-hand side. And what kind of factor am I going to do? Well, let's see. It's a quadratic trinomial. The first number is not a 1, so it's the not simple kind. So I'm going to have to do this, either guess and check or follow the steps, right? You probably come up with it pretty quickly by guessing and checking, but 2 times negative 35, negative 70. What are the factors of negative 70 that add up to negative 3? Well, I mean, we don't know too many factors of 70, but 1 times 70, 2 times 35, 3, no, 4, no, 5, 5, yes, 5 times 14, 6, no, how about 7 times 10? Okay, now since it's negative, we know one of those numbers is negative. Is it, since that's negative, right, this negative 3x, then we know that the bigger one is the negative. So which one of those adds up to negative 3? 7 and negative 10. So what do I do with those two numbers? I split up the middle term. 2x squared plus, or again, I've got a choice here, right? I can make it plus 7x minus 10x, or minus 10x plus 7x. And which way would I prefer to go? Negative first, right? In fact, the negative is better even for this reason too. Watch how it works, right? So 2x squared minus 10x plus 7x minus 35 equals 0. Now, what's the next step in factoring? Grouping, okay? But because there's going to be a plus in the middle of the parentheses, actually, I can group it on the same line. I don't need to write a new line. If it's a minus in between the parentheses, I'm going to have to change the sign of a term that comes later, and it probably should go on a new line. But for this one, let me just put the parentheses in right now, make sure that the plus is in between parentheses. Right? And now, factor the first set of parentheses. What's the greatest common factor? 2x. And what's left in the parentheses if I factor that out?
X minus 5.
Minus 5. Okay, what's the greatest common factor in the next set of parentheses?
7.
7 times x minus 5. Okay, which is good because that has to be the truth, right? The same thing in parentheses. Okay, last step of factoring is right? There's going to be an x minus 5. What goes in the other set of parentheses? 2x plus 7. Okay, so now we've changed it to a factored form equals 0. How do I solve?
You can put each one equal to 0.
I set each factor equal to 0. 2x plus 7 equals 0. X minus 5 equals 0. So 2x equals negative 7. X equals negative 7 halves. X equals 5. Yeah. Okay, try this one. I'm pretty sure it's a you try. Again, you don't have to factor like I factored. You could guess and check the factoring part of it. Both 3 and 7 are prime numbers. There are not going to be that many possibilities here. So again, here's a problem that with guessing and checking, I think you would have probably gotten it in about a minute, the factoring part of it, you know. But by trying to go through those 5 steps or whatever it is, it leads to a lot of errors. If you want to go through those steps, I mean, by all means, you're allowed to do that. 3 times 7 is 21. What are the factors of 21 that add up to 22? 1 and 21, right? So you would have to split this up. I'm going to show it on the bottom here. You would split this up. 3w squared plus w plus 21w plus 7 equals 0. All right, I'm going to group on the same line because I've got a plus in between parentheses. I'm going to factor a w times 3w plus 1 plus 7 times 3w plus 1. And now what's left? W plus 7 times 3w plus 1. Right, which is the same thing as I had there. You know, if the guessing and checking, you know where the guessing and checking falls down is if you have something like, you know, you do the A times C, the first times the last, and you get something like 72, right? And 72 has got how many factors? Like way more than you want to be guessing and checking to see what's right. Okay, then you need a process. But when you're given all these numbers that are just, they're almost all almost prime, if not prime. There's not much guessing and checking to do. Okay, so multiply. How do we multiply 2 binomials?
Foil.
You could foil, you could use the grid. In either case, I'm going to foil it, right? So,
The grid. Oh, you mean the algebra type? Oh, no, the other grid.
yeah, I mean, you could make a grid like this, right? And then do y plus 4 and y minus 4. You could do it like that. I'm going to foil. Y times y is y squared. Y times negative 4 is minus 4y. Okay, 4 times y is plus 4y. And 4 times negative 4 is minus 16. Combine like terms. Yeah, y squared minus 16, because the negative 4y and the positive 4y, they cancel, right? Try the same thing with x plus 3 times x minus 3. X squared minus 3x plus 3x minus 9. Combine like terms. Negative 3x plus 3x, they cancel. X squared minus 9. So notice the pattern there. I multiplied y plus 4 times y minus 4, and I got y squared minus 4 squared, 16. I multiplied x plus 3 times x minus 3. I got x squared minus 3 squared, which is x squared minus 9. What do you think I would get if I did x plus 5 times x minus 5? X squared minus 25, right? The 5x and the negative 5x would cancel, and all I would get is x squared minus 25. Okay, well, we're not so much interested in the multiplying. We're interested in going the opposite direction then. I mean, if I've got a pattern like y squared minus 16, that should tell me, okay, well, that must have been the result of y plus 4 times y minus 4. Or if I've got x squared minus 9, okay, it must have been x plus 3 times x minus 3. That's a factoring pattern which is called difference of squares. Just a second. It's called the difference of squares. A squared minus b squared equals a plus b times a minus b. Right. X squared minus 4 is x squared minus 2 squared. X plus 2 times x minus 2. I mean, this is where it comes in handy to know your perfect squares. Because when you get a two-term polynomial and both of those terms have got a perfect square in them somewhere, you got to be thinking, okay, well, this is probably a difference of squares. Okay, at this point, if it's not a difference of squares, it'd have to be greatest common factor, because then the only other thing we know how to do is the trinomial stuff. Right? So 25m squared minus 49, right? 25 is a perfect square. Right? So I can rewrite that term as 5m squared. 5m in parentheses squared, right? Properties of exponent says that's 5 squared m squared. 49 is 7 squared. So once I've got it as a difference of squares, then I apply the pattern, right? 5m plus 7, 5m minus 7. Okay. So, factor. X squared minus 25. Of course, you got to recognize 25 is a perfect square, so how does it factor? Somebody. Aiden. How does it factor? No idea. Blank. And yeah, factor it. No. How does it factor?
X plus 5.
X plus 5 times x minus 5. Okay, look at what you just did, right? X squared minus 4. X plus 2, x minus 2, right? X plus 5, x minus 5. How about x squared minus 144? X plus 12 times x minus 12. Factor. You can't solve something that is not an equation, right? So again, don't turn things into equations which are not equations. If you introduce an equal sign and just change the nature of the problem, you just lost all credit. Okay? Right? You're turning things into things they're not. Okay, so I mean, it's a fairly easy pattern once you recognize, right? X squared minus 81. X plus 9 times x minus 9, right? It only gets more complicated when you have like the previous one, like 25m squared. Okay, well now you got to think of that first term as like 5m squared. Okay, how about this one? Try that one. Again, it might help if you write it like the difference of squares, right? Difference meaning subtraction, and then something squared minus something squared, right? 36 is a perfect square. So how does it factor?
X plus 6. What is it?
X plus 6y times x minus 6y. Okay, now multiply. N plus 6 squared, right? That means n plus 6 times n plus 6. Okay, how do we do that? Foil, right? So that would be n squared plus 6n plus 6n plus 36, right? So it's the first term squared, n squared. It's the last term squared, 6 squared. And it's 2 times 6n plus 6n, the inner product, right? 6 times n plus 6 times n. So it's n squared plus 12n plus 36. Okay, how about the next one? 3x plus 2 times 3x plus 2, right? It should be the first term squared. What's 3x times 3x? 9x squared. 3x times 2 is 6x, and you do that twice, right? You get this one and this one, and then 2 times 2 is 4. So again, it's the first term squared plus the last term squared plus 2 times the inner product, 3x times 2. Again, we're not interested in the multiplying as much as we are. Now that we see what happens when you square a binomial, then that ought to help us to factor sometimes. That it's a special factoring pattern that we should know, right? Like in this one, I should say 9x squared. I can see that that's 3x in parentheses squared. The last one is 2 squared. So the only thing to check is the middle term 2 times 3x times 2? Right? If this is a perfect square trinomial, then it should be that the middle term would be 2 times 3x times 2. Is it? Is 2 times 3x times 2 12x? it is, right? So that's 3x plus 2 squared. So you got to recognize perfect squares, right? Square, square. And then just play with the middle term and see whether it would be the appropriate middle term. It's possible for it not to be, but I think at this level it won't be. What's the difference between these two?
-12.
So how do you think that's going to change how it factors?
Maybe negative something.
It'll be 3x minus 2. How could you check it? Foil. Just see if you got the right thing if you foiled it. Okay. So I'll stop it right away. That's called a perfect square trinomial. When you get a trinomial that can be factored like a binomial squared, that's called a perfect square trinomial. And again, it's a factoring pattern. It's a little harder to recognize than the difference of squares, right? The pattern is a squared plus 2ab plus b squared. You know, it's got to be the first term squared, the last term squared, and 2 times the inner product. If it meets the pattern, then you know that it's a plus b squared. I mean, if you didn't factor it like it was a special pattern, you could look at it and say, well, that's one of those not simple quadratic trinomials. What if I said 4 times 25 is 100? What are the factors of 100 that add up to 20? 10 and 10, right? So you could just factor it that way and just forget about the special pattern, right? So you don't have to know this as a special pattern if you know how to factor the quadratic trinomial, right? That doesn't start with a 1. I mean, sometimes they do start with a 1. Okay. So, I mean, even this one here, that meets the pattern of a perfect square trinomial, but it also just a simple quadratic trinomial. What are the factors of 4 that add up to 4? 2 and 2. So how does it factor? Right? The factors of 4 that add up to 4 are 2 and 2. H plus 2 times h plus 2 is h plus 2 squared. So that's a perfect square trinomial. Okay, I'm going to go quickly through this end thing here. Don't worry about that. We're not going to do that. So the only other possibility here is we've done the greatest common factor. We've done the quadratic trinomials, and we saw these 2 special patterns today. But sometimes it's a combination. It's not just one kind of factoring that you have to do, which means it's going to be, if it is, it's going to be greatest common factor first, and then, where's my hands? Forget it. And then do something else. I'll just show you one and then we'll be done. So like on this one here, if you looked at that, you might think, well, I'm going to have to go through either a guess and check, or I'm going to have to do the long process. 2 times 24 is 48. Think of the factors of 48 that add up to negative 16, right? But in the end, there's actually a common factor in every one of those. What is it? There's a 2. You could factor out a 2 on the first step, and this problem will look a lot different. Now it's t squared minus 8t plus 12. Okay, now what's inside parentheses, I don't need to go through the long process anymore. I just have to think of what are the factors of 12 that add up to negative 8. Right? What are the factors of 12 that add? t minus 6 times t minus 2. Right, so it was actually an easier kind of factoring if I just saw the greatest common factor first. Okay, now what are the solutions? Okay, now remember, if you have a product and it equals 0, that means one of the factors equals 0. Okay, 2 is never going to equal 0. It equals 2. So the constant is not a source of a solution. The solutions come from these two. And what are they? Just by inspection, what are they? 6 and 2. You don't have to make an equation for if it's just like t minus 6. You could just say, what value would I plug in there and make that 0? 6. So t equals 6 and 2. Right? And this is not a source of a solution. In fact, you could have just divided both sides by 2, and it would be gone. Right? Because what's 0 divided by 2? 0. So it wouldn't change anything if I just divide everything by 2, get rid of it. Okay. And I'm just going to show us what's the greatest common factor between those two? 2. So notice if I factor out a 2, now I've got a difference of squares. Right? That is 2 times 3n plus 2 times 3n minus 2. Right? You don't recognize it when it's got 18 and 8 because neither one is a perfect square. But when you take out a 2, you do. And we're not going to do that. Not enough time. Sorry, it was too long today. But you got the basics.